this is no magic, we're learning physics with magical. Today our new topic will be forces, density and pressure. We'll begin first of all with forces. In Newton's first law, we realize that object can either be in a constant speed or an object can be just stationary. In Newton's second law, we realize that if the speed changes, let's say it increases, that means you start off with u and your v is greater than your u. Therefore, in order to increase it, or when it increases, we call it acceleration. And in order to increase it, a force must be provided to the object in order for it to increase. Hence, we got the equation, resultant force is equal to m. Similarly, if we have a decrease in speed, where your u, but your v is now less than u, therefore deceleration has occurred. And in order for deceleration, you also need a force applied. In this case, the force with the same direction as the direction of motion to increase the speed. In this case, you have a force is quite opposite direction to the motion, so that you have a deceleration. All this takes into account that the object is a point mass. That means you're applying the force onto a point mass. What happens if you don't have a point mass? Most objects is not a point mass. What happens if you got a ruler? Okay, let's call this a meter rule. How do you make the meter rule go forward? Easy. You look for something called its center of gravity. In this case, it will be exactly, hopefully, at the 50 centimeter mark. And when you apply a force here, the whole object will literally move forward. So you literally get another meter rule at a displacement x apart. Remember, displacement is given by symbol s. But what happens if you don't hit the 50 centimeter mark? If you ask anyone, it's quite obvious. If you apply a force here, not at the center of gravity, in a meter rule, what will happen? You already know the object will turn. If you apply the force on the bottom, what happens? The object will turn. Okay? The description of this observation is quite obvious. So we end up with a new term. In this case, we've got point moments. You can say moments is just basically an equation that tells you how do you measure this turning effect. Okay? You have one force, so you put out one force times the perpendicular distance between the force and the heat. So in this case, if your pivot is here, then notice here the perpendicular distance will be this guy here. This is taking into consideration that this is the heat. Pivot is just a point in which, you can still call it a hinge as well, in which the object is literally, when it turns, you notice this part is the part where it will not turn. Okay? This is all the parts will turn except for this point. Just like a door. When you have a door, when you turn it, there's one part of the door that does not turn. Okay? And usually on the opposite end of the handle. So here's the handle, you open close, and then here you have the pivot. So that is what is meant pivot. And then in calculation, moments equal to one force times perpendicular distance between force and pivot. In the next component, we'll be talking on how to use this equation.